In this video, I'm going to talk about DeMoivres theorem and an example. So DeMoivres theorem is a theorem which relates complex number with trigonometric function. So any complex number a plus ib can be written as r into cos theta plus I sin theta. So if we take z as this complex number, then r into cos theta plus I sin theta is equal to z. So when we multiply this z with itself, that is z square, we see that z square is equal to r square into cos theta plus I sin theta the whole square, that is equal to r square into cos square theta plus I square sin square theta plus 2i cos theta sin theta by a plus b the whole square formula. So that is equal to r square into cos square theta minus sin square theta plus I into 2 cos theta sin theta. So that is equal to r square into cos 2 theta plus I sin 2 theta. Why this cos 2 theta and sin 2 theta means cos of a plus b formula and sin of a plus b formula. Cos of a plus b is equal to cos a cos b minus sin a sin b, which implies this cos of theta plus theta is equal to cos square theta minus sin square theta. So sin of a plus b, so sin of theta plus theta, sin 2 theta equal to 2 cos theta sin theta. So we see that when a complex number is squared, the absolute value of it is squared, that is r square, and the argument, that is theta, is multiplied by 2 times. When we square, it is multiplied with that number 2. If we cube the complex number means this, similarly if we cube this complex number means we get cos 3 theta plus I sin 3 theta and r cube. So we see that the absolute value is cubed or squared based on what we do to the complex number, and the argument is multiplied by the power which we raise. So the argument is multiplied by the value n. So this is what is DeMoivres theorem. So DeMoivres theorem is r into that is cos theta plus I sin theta the whole power n is equal to cos n theta plus I sin n theta. So this is what the DeMoivres theorem states, that it leaves out the r value. It takes it takes the value of r as 1, that is unit circle. The value of the complex number lies in a unit circle. It assumes the r value as 1. Therefore cos theta plus I sin theta the whole power n equal to cos n theta plus I sin n theta. How it can be stated it as, that is the corollary, a proposition that follows from one already proved, is if a number on a unit circle, a complex number on a unit circle is taken with, that is with length 1 and multiply by itself, the number will simply rotate around the unit circle by that by angle theta. So when we cube, that means it will again rotate by an angle theta. It will keep on rotating in the unit circle. This is a power generator. It is like a power generator. It is just keep on generating the power with, but it is going to lie on an unit circle. So this DeMoivres theorem, we will use it for an example. It has some applications. One of the few applications are like finding the roots of a polynomial which involves complex numbers. If any polynomial is going to involve complex numbers, then this theorem can be used to find out the roots of the polynomial equation, and it relates the power with the argument, that is sin square theta with sin 2 theta, so on and so forth, that is power with the angle theta. So these things are there, and the example is, if you see, so in order to see an example of DeMoivres theorem, we will take the case where we have to prove cos 8 theta is equal to 1 minus 32 sin square theta plus 160 sine power 4 theta minus 256 sine power 6 theta plus 128 sine power 8 theta. So we will see that we will take the LHS alone left hand side. So cos theta plus I sin theta the whole power 8 is equal to by binomial theorem we will expand, that is equal to 8c0 into cos power 8 theta plus 8c1 into cos power 7 theta into I sin theta minus y minus means I square. So 8c2 minus 8c2 into cos power 6 theta into sin square theta. So the I also is getting squared, that I square is going in front of it as minus. So minus minus 8c2 cos power 6 theta into sin square theta minus 8c3 cos power 5 theta into I sin cube theta. So I square is minus and the another I is in front of the sin cube theta, and so on. All these values comes forth. So cos 8 theta plus I sin 8 theta equal to cos power 8 theta plus 8i cos power 7 theta into sin theta minus 28 cos power 6 theta into sin square theta minus 56i cos power 5 theta into sin cube theta plus 70 cos power 4 theta into sin power 4 theta plus 56i cos cube theta into sin power 5 theta minus 28 cos square theta sin power 6 theta minus 8i cos theta sin power 7 theta plus sin power 8 theta. So we will equate the like terms, that is real term with the real term and the imaginary term with the imaginary term, and we will arrive at the answer like cos 8 theta is equal to cos power 8 theta minus 28 cos power 6 theta sin square theta plus 70 cos power 4 theta sin power 4 theta minus 28 cos square theta into sin power 6 theta plus sin power 8 theta. So another thing is equating with the imaginary term, we get the value of sin 8 theta. So whenever this kind of question is asked, or whenever we would like to see what this term is in real, like the expansion of this term, we will rise to this power, use the DeMoivres theorem, use a binomial theorem, and then we will finally arrive at the by equating the like terms we will arrive at the answer. This is how this is done. Thank you.